We're moving on to 6.2.2 now. 6.2.1, we saw systems of three equations with three solutions. Sometimes, though, we try to follow those four steps, and what happens is we either get no solution or we might have infinitely many solutions. Think about the way the planes might intersect. For the first, for 6.2.1, our planes intersected at one point. But for 6.2.2, we're going to find that sometimes they never intersect, like parallel planes, and sometimes they intersect at a line. So we get infinitely many solutions. So you can look at your textbook for some pictures of that to help you visualize that, but the solution might become into a single line. Okay, so let's look at number 18. So now we're focusing again on just a little piece of your homework here. So 17 and 25. So let's see, we got a couple in there that have no solution or many solutions. So 18, let's see what 18's like. We're going to try to follow those same steps as before, so I'll color code that again. So starting with step 1, I want to number my equations again so I can keep track of what I'm doing. And in step 1, we try to reduce this system of equations to two equations in two variables. So trying to create a smaller system of two equations. So the first thing I do here is look at these three equations and what variable could I eliminate? And you'll notice there's nothing that just eliminates immediately by adding two equations together as they are written, because there's no variable that has common coefficients. So we're going to have to take a multiple of one of the equations. So let's pick out these two, and let's try to eliminate the variable c. And that was pretty random. You could pick any two and pick any variable. But since I have the choice, I'll just pick 1 and 2 and pick variable c. So we'll try to eliminate z. Okay, so if I combine 1 and 2, to do that, I'm going to need a 4 here, right? So if I get a plus 4z and a minus 4z, then my z's will drop out. So to get that 4 in there, I have to multiply equation 2 by 4. Whatever I do to z, I got to do to the whole equation. So I'm going to start with equation 1 and add 4 times equation 2. So equation 1 I'll just copy down. I'm not changing that one. And equation 2, I'm going to multiply the whole equation by -4 so I don't change the equality. And I get -4 times 4 is -16x. -3y times 4 gives me -12y. Negative z gives me 4z. That's by design. That was my whole goal. Whoops, that should be a negative. Sorry. Oh, shoot. And then equals -15 times 4 gives me a -60. All right, just glancing over that, make sure I didn't make any multiplication errors or sign errors. Looks good. And then adding those two equations together is going to give me a fourth equation. I get, let's see, -47 here. My z's drop out. My y's, I get -13y. And my x's, I get a -13x equals -47. All right, so that's one of my equations. All right, now let's pick two other equations and again get z to drop out. So I can't do 1 and 2 again because I already did those. So what am I going to do now? Let's see. I could do 2 and 3. No, I'm going to need a -3 in front of here now. So to get that 3 in there, so my positive 3z and my negative 3z will drop out. So I'm going to start with equation 3 and add 3 times equation 2. Okay, so 3 is x minus 2y plus 3z equals 12. And 3 times equation 2 is negative 12x minus, 3 times 3 is 9y minus 3 times 1 is 3. And then negative 15 times 3 gives me negative 45. Okay, adding those two equations together, I should number these equations. I like to have names on them, so I'll call that equation 4. And this one's going to be equation 5. So I get a negative 33 here. My z's drop out. My y is now negative 11y. And my x is negative 11x. So I now have negative 11x minus 11y equals negative 33. Actually, you know what I'm going to do with that one? Since 33 is a multiple of 11, that one I'm going to reduce because, again, I like to keep my numbers small so I can write an equivalent equation by dividing this entire thing by negative 11, and I get x, I'll write a little lower here, x minus y equals negative 3. So that's a little prettier equation. I like smaller numbers. All right, so that's my equation 5. All right, so I have a new system. So step 1 is done. So moving on to step 2. Now I take that system and try to solve for x and y. So let's see. I'm gonna, you know what? Sorry. When I simplified equation 5, I multiplied by negative 11, but I forgot to change the sign on this one and this one. So that should be a y, x plus y equals a positive 3. All right, so that's just dividing that solution by negative 11. Okay, back to step 2. So this one I'm going to use substitution. It doesn't eliminate very easily unless I multiply everything by 13, but then I get numbers big again. So I'm going to just do substitution. So I'm going to solve equation 5 for let's solve that for y, and I get y equals 3 minus x. And substituting that into equation 4. So I'm subbing 5 into 4. So write my equation 4. I have negative 13x minus 13y equals a negative 47. Plugging in my 3 minus x and 4y, I get negative 13x minus 13 times 3 minus x equals negative 47. So on the left, I get negative 13x minus, distributing my 13, I get 39. And negative 13 times negative x is plus 13x. Equals negative 47. So on the left, my 13x and negative 13x will cancel, which leaves me just with the negative 39. And on the right, I still have negative 47. So now I have a statement that is never true. Negative 39 equals negative 47. When does that happen? That happens never. So that means there's no solution. This is false. So if I manipulate these equations without breaking any algebra rules, and I get something that's false, I haven't put any numbers in for x and y yet, but it's not true. So that means it's never going to be true. So there's no solution which means these planes do not intersect. The three planes don't intersect. Let's see. I guess that's it for that one. So I just say no solutions. Actually, I just say solution. So if you get something false, two constants that do not equal each other, something that's never ever true, then you can say there's no solution. That one's harder to check. So to check that one, go back in your work and make sure that you didn't just make an error.